Hello everyone. I come up with an interesting and very important topic of mathematics today, which is known as trigonometry in three dimensions. So here we will learn few sums where we can see trigonometry in three dimensions. So let us see question number 1. There are three parts in it. The first part is to calculate the length HF. Now if you look at it, the diagram which is given with the question, it is a cube with different vertices, 8 vertices denoted by A, B, C, D, E, F, G and H. We see in the bottom face E, F, G, H. There are 6 faces of a cube and they all are squares, and we have to see H and F. They are lying in the bottom of the cube, so they are the vertices of a square in the bottom of a cube. Let us see this in three-dimensional shape where HF lies and how we can use trigonometry in it. So if we look at in this diagram, three-dimensional shape, we can rotate and we can see it. When you join H and F, yeah, here I have joined by pink color line, and we form a right angle triangle which is colored here, and it is going to be 90 degree at point G. So what we need to understand in three-dimensional shape, we have to make a two-dimensional shape and we have to use trigonometry in it. So if you look in this diagram, however, it's difficult to understand from the given diagram with the question, but here easily you can understand by rotating this shape where triangle is going to be formed and what degree angle and what are the sides. So here we clearly, it's the HFG is a right angle triangle and G is the 90 degree, and there are two sides are known to us, HG, that is 4 centimeter, and FG is also 4 centimeter. So we will draw this diagram in 2D, and then we will use trigonometry to find out the unknown. So let us see in. So if you draw the right angle triangle, it would look like this. In pink color right angle triangle, here you can see HGF. Now we need to find HF, and two sides of right angle triangle are known. Then we can use Pythagoras theorem to find the unknown side. So what should I write is, in right triangle, yeah, this statement will come almost in all the questions. In right triangle I write HGF. By Pythagoras theorem we are having HF square. HF square means hypotenuse square is equal to sum of the squares of other two sides, that are 4 square and 4 square over here. So this sum is going to be 32. So HF squares value I got 32. Now if you take out the square root both the sides, I am going to get a root of 32, which is same as, if you write in number, then it is coming up 5.66. it is rounding up to three significant figures, 5.66. So this is the answer of the first part of the question. Moving for the second part in the question, if you see, second part is to calculate the length HB. Now see where is H and where is B. H is lying in the bottom, B is lying on the top corner. So when you join them, they will also form the triangle, and where they will form the triangle is very easy to see in three-dimensional shape rather than this diagram. So we move to the three-dimensional shape to understand how it's going to be form a triangle there. So here it is in this diagram, easily we can see when you join H and B, it will form the triangle. I use violet color to denote it. If you rotate this shape, you can understand where this triangle is going to be formed. H F B is going to be a right angle triangle there, and 90 degree will be at point F. So you rotate and you can check where is going to be formed. But we'll draw this in two-dimensional shape. We'll draw only triangle because we want to find unknown HB, and HB is the hypotenuse of the right angle triangle HFB. So let us move to the two-dimensional shape. So here we can see a right angle triangle HFB in two-dimensional shape. HF is 5.66, just we obtained in the previous part. Also you can say it is root of 32, and BF is 4 centimeter. So in this right angle triangle I use again Pythagoras theorem. So I need to write in right triangle HFB by Pythagoras theorem, hypotenuse square. Hypotenuse is the longest side in right angle triangle, or side opposite to the 90-degree, is equal to I write root of 32 instead of 5.66 is the same, but to get more accurate answer, root of 32 square and 4 square. Now if you work out this by calculator, is 32 plus 16, which is coming up 48. So this is HB square, but I need HB, so it is root of 48, and since it is a length is always positive, and if you write in decimal point, is coming up 6.93, correct to 3 significant figure. So HB is 6.93 centimeter. This is the answer, final answer of the B part of the question. Now moving further for the C part, let us go to the question again. C part is to calculate the angle BHG. So you can see when you join BHG is again going to be a triangle. So let us see how it will be a triangle, where it will be 90-degree, or what are the sides. It's easy to understand in three-dimensional shape. So we'll move to 3D shape to understand this. So this is the 3D shape for the 3D view. So when you join H and B and B and G and then G and H, it's going to be a triangle like this, pink color shape. You can check here in the yellow color cube. So it's easy to understand that when you join HG is going to be a diagonal of one of the face of a cube, and when you join GH, so it's going to be a 90-degree at point G. So it's going to be a right angle triangle, which is BGH. You can see from the back side also how it would look like. See, by moving this cube like this. Yeah, so we'll draw this right angle triangle in 2D shape to understand it. Let us move. So in the third part, we want to get the angle BHG. So actually we want to find the angle in this 2D diagram. We can see right angle triangle, this angle we denote by theta, so we have to find theta in this case. So what we'll write is, in right angle triangle, or in right triangle, you can say BGH, or you can write HGB. I apply see, it's opposite side and adjacent and hypotenuse, everything is known to us, but HG is very much clear, which is one edge of the cube, which is 4, and HB we already obtained somewhere in the previous part, which is coming root of 48, which is 6.93. So I use from theta, if you see, adjacent side is HG, which is 4, and hypotenuse is 6.93. So I will use cosine rule to calculate the angle. So I apply cosine rule. So cos theta is adjacent side to it is 4 upon is hypotenuse, it is root of 48. I write instead of 6.93, it is same, root of 48. So I need to apply trigonometry to get the angle, inverse trigonometry. So theta is equal to, if you take cos inverse both the sides, I am going to get cos inverse 4 upon root of 48. Okay, and when you find out this answer using calculator, it's coming up approximately 54.7 degree in degree form. So this is my answer of the angle BHG. which is coming up 54.7 degree. So this is the answer of the third part of the question number 1. We will discuss next question, that is question number 5, which is based on the pyramid. Here in the diagram with the question they have given a right pyramid. Now the base of the pyramid is a rectangle and it is having some height. Height is not mentioned, but the slant height is given, which is AB 10 cm. Base rectangle's dimensions are 6 cm by 4 cm, which we can see in the diagram. Now as per the question, there are two parts, each will contain two parts, so total 4 parts are there in the question. The first, calculate the length dB. Now dB, if you see, it is lying in the base of a triangle, base of the pyramid, which is a diagonal of a rectangle, base rectangle. So let us see in 3D shape where BD lies exactly. So look at it, this shape is denoted by green color triangle. When you join BD, they are going to form two right angle triangles. One is BDE and another one is BCD. So both are right angle triangles. Since it is a rectangle, base is a rectangle, and they form the triangle 90-degree angle at E and C differently. But we'll use this green color right angle triangle because we want to calculate the length BD. So two sides are known of this right angle triangle, which are 6 cm and 4 cm. So let us come to the 2D shape for this. Okay, so A first, here is forming a right angle triangle, so I write in right triangle, say BED. By Pythagoras theorem, BD square is equal to 6 square plus 4 square. If you simplify it, going to get 52. So by taking our square root both these sides, it will give us root of 52, and to 3 significant figure, if you round off this number and decimal point, is coming up 7.21 centimeter. So this is the answer of the first part of the first question. BD just is the hypotenuse of a right angle triangle. We got it. Moving for the second part of the first question, calculate the angle DAX. So let us see where is DAX. So again, when you think only these 3 points in this 3 dimension, if you join them and if you pass a plane passing through 3 points, they are forming a right angle triangle. So let us see in 3D shape. When you see in 3 dimensions and when you join DAX point, they are forming a triangle, 2-dimensional plane. Here you can see it is denoted by a little green color over here. So this is a right angle triangle at angle X. By moving this pyramid, we can see this. And we want to calculate the angle from this triangle. So I will draw this right angle triangle in 2 dimensions and I can use it. So in this right angle triangle DAX, I need to calculate the angle A. So I denote this angle by say theta. So theta I have to calculate. Now if you see in this triangle, we have opposite side, which is DX, which is half of the DA. Right, DA is the diagonal which we obtain, is a half of DB. DB is the diagonal which we obtain in the first part of the first just previously, which is come up around 7.21. So first of all I have to calculate DX. DX is half of DB, yeah, and DB just we obtain in the previous part. Its value is approximately 7.21 or root of 52. So when you calculate this, is coming up 3.6055 centimeters. So this is the length of DX. I need to use DX is half of DB because X is a midpoint of DB, that we can see since it is a right pyramid. Now in triangle, in this right triangle I use trigonometry to get angle. So in right triangle I say DAX. Now see, from theta if you see is opposite side and hypotenuse is given, so I will go for sine function. Sine theta if I find is opposite side is 3.6055 and its hypotenuse is 10. So when you keep this and when you find the angle theta is coming sine inverse, when you divide by 10 is 0.36055 and its value is approximately 21.1 degree, if you correct to three significant figures by rounding up to three significant figures. This is the answer is in the degree, 21.1 degree. Let us move to the second B part of the question. Calculate the angle CED. When you see CED, they all 3 points vertices lying on the base rectangle. They are endpoints of the base rectangle. So it's very easy to understand that they are forming a right angle triangle CDE. CD is 4 centimeter, D is 6 centimeter, which is given. Also we see in 3D shape. So in 3D shape here we have right angle triangle in green color. Easily we can see that it's angle 90 degree at point D, and the angle which we want to find here, it is denoted by beta sign, angle E, which is dark green color, which we want to find. So this is its 3D view. It's a base right angle triangle in the base. Yeah, we can draw even 2D shape for it. So let us see 2D shape and we work out this angle using trigonometry. So in this green color right angle triangle, we want to find angle. So I write in right triangle, say CDE, the angle which I want to find E, which I denote by suppose say theta. So from theta if you see is opposite side and adjacent side is given, so I would use obviously tan theta in this triangle. So tan theta is equal to opposite side is 4, adjacent side is 6, and when you find theta from here is coming up tan inverse 4 by 6. So theta is coming approximately 33.7 degree. So we can say that this angle and which we want to find, which is CED, is coming around 33.7 degree, rounding up to again three significant figures. So this is the answer of the first part of B. Moving further, the second part, B2. If you see in this question, B2 is to calculate the angle DBA. DBA angle. So when you join DBA is going to be an isosceles triangle, because AB and AD are two edges. Here we can see, and they both are slant height of the pyramid, which are 10 centimeter, and BD will be the base and X will be the midpoint of BD, since it is a perpendicular, and also it's an isosceles triangle, so it's going to be median. Okay, so we want to get the angle DBA. Instead of that, since D, X and B lying on the same line, we can find angle XBA. Instead of DBA, we can find the angle XBA. They are one and same. Okay, since D, X and B lying on the same line, that we can see. Now moving further for 3D view of it. So when you join ABX, because we want to get DBA angle, we'll find XB angle. So I marked only XBA triangle only. XBA triangle, it would look like this, and angle B, which is marked by a dark green color, which we want to find. This is the 3D view of this. Yeah, we can see. So basically what I need to get angle is opposite side, maybe AX I need, maybe BX I need, and this lens we are having already. So we draw this right angle triangle in 2D and we can understand it. So let us see in 2D shape. So here we'll use right angle triangle AXB, which can be seen in the this green color triangle. I mark this angle by theta, which I want to find. So theta, and now bx is half of, easily we can see bx is half of bd. Bd is the diagonal of the base rectangle. This value we already had. uh, so bx is equal to ba half of bd. Now value of bd we had obtained. The value of bd is approximately it was 7.21, but we can put a root of 52 and we work out is coming around 3.6055. Yeah, now this bx we can see in this triangle, green color triangle, bx length, and another length which I want to obtain uh, is AB, which is given already, 10 centimeter. Now use trigonometry to get angle theta. So from theta, if you see, it's adjacent side and hypotenuse is given. So I will go for right angle triangle AXB and I use cosine rule, cos function, cos trigonometric ratio to get theta, because adjacent side and hypotenuse is given to theta. So in right triangle I can say A B X cos theta is equal to adjacent side to this is 3.6055 and its hypotenuse is 10. So when you work out theta from this is coming up cos inverse 0.36055, and when you find theta from this is cos inverse this, which is coming up 68.9 degree approximately. So this is the angle. You can say XBA or you can say is same as DBA, both are one and same. Okay, so this answer is 68.9 degree, and this is correct to three significant figures. Yeah, so this is the answer of the B second question. So this is how we can use trigonometry in 3D shape. Only thing is very difficult to view 2D shape in given three-dimensional shape. So I tried to make this video which can help us to see 2D shape in three-dimensional shape, yeah, with animations. Thank you very much. Some more questions based on this you can see in the another part of the video. This was the first part of the use of trigonometry in 3D. Thank you very much.